Hello there, chemistry students. All right, so I'm going to do a little bit of a lesson today based upon those exit slips I've been looking at. And I want to start off by us looking at this piece of paper. So if you could have that out, that'd be awesome. All right. So the thing with this is a sheet of all the ions. All right, ions. Meaning you're only going to be using this when we're talking about ionic bonding. You should never be looking at this sheet when we're looking at molecular bonds, because these are ions and there are no ions in molecular bonds. So that's the first thing I want to point out. Another thing you should notice is I've organized this thing by charge. So everything that's +1, +2, +3, so on. I've also done it alphabetically. You'll notice that if a metal can have more than one charge, I indicate it with a Roman numeral after its name, indicating that this is a +2 charge. Notice that titanium can also be a +3. And if you were to look at the periodic table, you're going to find that some of these metals that I listed, I think titanium is one of them, can have more than this, just these charges, and I've only put these on my piece of paper. I could have put every ion that can have multiple charges on the sheet, but then the sheet would be so much more full than what it is. All right, so you'll also notice at the top, these are all your monatomic ones. So these are just a single atom that has a charge. On the bottom is the polyatomic ions. All right, the polyatomic ions are ones that are made up of 2 or more atoms. They can be 2 of the same atoms, or 2 different atoms, or more than 2 atoms. Again, I've organized it so that the positive ones are first, and there's only 2 of them, right? There's only 2. Where we have a lot of them are the negative ones, and I've organized those by number and also in alphabetical order. I have found that some of my students are having difficulty seeing this 7 in the dichromate, Cr2O7. There's 7 oxygens and 2 chromiums, so a total of 9 atoms that make up this dichromate polyatomic ion, that then these 9 atoms all together have a -2 charge. All right, so if you feel like you need to write that 7 a little bit darker on your photocopy, then go ahead and do so. I'm giving you permission to do that. All right. Now on this paper, there should be no other writing that you have on here other than your name. I should not see writing on the back side, right? There's no putting your prefixes on or anything else like that. All right, so we're going to be using this sheet in a little bit, but I want to talk with you guys about some of the things I saw when I did your exit slips. All right. So whenever you look at a compound, the first thing I want you to do is look at the first element and see if it's a metal, and then you know you're going to be using this sheet. And the only other exception of having not a metal is if you have NH4, because remember that is a cation, and there is no metal in this, but it is considered a cation. So this is your one exception of a non-metal that starts off a compound in it being ionic. Okay, so you see that the first one is silver, right? So now we have to ask ourselves, can silver have more than one charge? And if you come back to this piece of paper here, you'll see my silver does not have a Roman numeral after it. Silver is one of the transition metals that is always a distinct charge. It's always going to be a +1. A couple other ones that will always be like that is zinc is always a +2, as well as cadmium is a transition metal, is a +2. And then right over here, scandium is always a +3. And if you look at your periodic table, you're going to find that I think zinc, cadmium, and silver are all near one another on the periodic table, right? So those are transition metals that have a distinct charge, and so therefore no Roman numeral will be in this name. So now we look at the second half of this thing, and if you need to go to your yellow sheet, or if you have it memorized, or you look in the front of my classroom, you'll see that SO4 has the name of sulfate. And so this thing is silver sulfate. All right. So this one, first one is Mg, it's a metal, and it's magnesium. So then we look at magnesium. Can magnesium have more than one charge? If you're not sure, go to this paper, find where magnesium is. Notice there is no Roman numeral. It will always be a +2 charge, so we don't put a Roman numeral on there. And then the S, when it's a monatomic ion like this, should end in IDE. So the name is going to be sulfide. So if we go and look at this paper and try to find one of those metals that can be more than one charge, right? You should notice nickel right here. If we come back to this paper, nickel is listed here as a 2. Nickel is also listed here as a 3. All right? So we need to, when we name this one, use a Roman numeral, but you have to decide which Roman numeral, and you decide based upon the negative ion that's with it. This chlorine is a -1. There's 3 of those chlorines for a total of -3. Since this negative charge is -3, and there's 1 nickel here, that nickel has to be a +3. So when we name it, we're going to name it nickel 3 chloride. Okay, do you see any other metals on here that can have more than one charge? All right, if you're looking at number 6, titanium is one of those. And when you see titanium here, it can be a +2 or a +3, right? So go to this, look at your negative ion. Oxide is a -2. There's 1 titanium to go with it, so it has to be a +2. So we'll name this titanium, Roman numeral 2, oxide. All right. Do you see any other ones that have a metal that can be more than one charge? All right, you should see this one right here, tin. Okay, look at our sheet here. Tin can be a 2. Tin can also be a 4. Okay? So we have to look at our negative ion. This is a chromate ion. So if you look for the chromate ion on your ion sheet, you'll see that it's a -2 charge. Notice we have 2 chromates here, right? So there's 2 chromates for a total of -4. Since there's only 1 tin here, it has to be +4 to offset the charge of the 2 chromates. So the name of this one will be tin, Roman numeral 4, chromate. All right? So please do not get this naming that we're using here mixed up with those things that are molecular. Molecular compounds have only nonmetals in them. So if you look at this, phosphorus is a nonmetal and chlorine is a nonmetal. And because these are 2 nonmetals, we are never going to look at this sheet because these are ions, and we know that if we had 2 nonmetals, a negative and a negative wouldn't come together because same charges repel one another. So these are not going to be ions. These come together because they're going to share electrons rather than what these guys do, which is losing and gaining electrons. This guy lost electrons to be positive. This one gained electrons to be negative. So there's a transferring of electrons. That's not what happens here when we have 2 nonmetals. 2 nonmetals do a lot of sharing. And because they don't make ions, we can't name them using ions. We have to name them without knowing charges. So P is just plain old phosphorus. And whenever you have one of the first element, you never use a prefix on it. But the second element should always have a prefix on it that tells you how many. Whether there's 1 or more than 1, you should always have a prefix. So the prefix for 3 is tri. And then we're going to use this name, chlorine, and change the ending to chloride. And so we have phosphorus trichloride. Skipping down to number 14 here, we got 2. The prefix for 2 is di. Then we name the first element without changing its name. And the second one, the prefix for 4 is tetra. And that's fluorine, but we need to change the ending to fluoride. And so we have disulfur tetrafluoride. All right. You're going to notice that these here are acids. Acids are for extra credit, so I'm not going to talk about those. So if you wanted to do the extra credit, you'll have to do the extra credit packet in order to do those. So I'm going to flip my page over. And now I want to talk about how to write formulas for these. So if we're talking about ionic structures, because we can have ionic or molecular things that you're going to be tested on. Remember, acids are only extra credit, so I'm not going to talk about those. So ionic or molecular, if you're talking about ionic things, we're talking about things with charges to them. So we know we just talked about nickel can be more than one charge, and specifically this nickel is a +2 charge. So I'm going to write +2 to remind myself that nickel is +2. Now phosphite, when you look at your yellow sheet, is a PO3 ion that has a -3 charge. So we need this +2 and this -3 to cancel out to make sure we have something that's electrically neutral. In order for that to happen, you're going to need to have 3 nickels for a total of +6. And then we need 2 phosphites. So I'm going to keep the formula for phosphite without changing it, put in parentheses, and show that I need to have 2 of those phosphites. So 2 of these -3 charges will be -6, and 3 of these +2 charges will be +6, and now I have something that's electrically neutral. Iron is another one where it has more than one charge, and we're told it's a +3. So I'm going to write +3 as a way just to focus on that charge. And then acetate ion is written as CH3COO, and it's got a -1 charge. So to make this one electrically neutral, I don't need to have more irons. I do need to have a total of 3 acetates, because that will then be -3 to cancel out with this. So I'm going to just write 1 iron, and then acetate is going to be in parentheses because I need to have many of these, and I'll show that I'll have 3 of those, and that will be electrically neutral. All right. So here is a simple binary compound. We got cadmium. Cadmium is one of those metals that will only ever be +2. And fluoride is just a single monatomic ion with a -1 charge to it. So you can see we're going to need multiple fluorines to go with the cadmium to make this electrically neutral, but you do not put parentheses around the fluorine. Fluorine is not a polyatomic ion. I just need to put a little subscript here saying I need 2 of these fluorines, or 2 fluorides, to go with the 1 cadmium, and this will be electrically neutral. If you put parentheses around monatomic ions, I do mark it wrong. If you forget to put parentheses around polyatomic ions, I do mark it wrong. So you have to make sure you write them correctly. All right? So let's do number 25 with lithium hydrogen phosphate. Lithium is a +1 charged ion on here. And then hydrogen phosphate is written as HPO4. And when you look for it on your ion sheet, you'll see that it has a -2 charge. All right. So this time I'm going to need multiple of the positive ions to offset the charge of the negative. I'm going to need a total of 2 lithium to go with the 1 hydrogen phosphate. Notice no parentheses around the hydrogen phosphate because there's only 1 of them. And because lithium is a monatomic ion, I don't put parentheses around it. So I have 2 of these +1 charges to offset the charge of this -2 hydrogen phosphate, and it's electrically neutral. I highly suggest when you're doing this to write these charges down by the names. And if you have polyatomic ions, rewrite the whole polyatomic ion with this charge, because that is a great way to focus on how to make sure this is electrically neutral. When it comes to naming molecular compounds, you'll notice that there'll be prefixes in the name. Tetra. Tetra means 4. So I'm going to have 4 carbons. Deca means 10, like in a decade. I'm going to have 10 oxygens. And there's your formula. All right? Di means 2. And we have to have 2 hydrogens. Mon, or mono, means 1. I need 1 oxygen. There's your formula. All right? Again, with the acids, I'm not going to do anything with those right now because those are for extra credit. So if you wanted to do those, You do those on your own time. I hope my little lesson here has helped you in writing formulas and in names. If there's anything that you still have questions about, please make sure you email me at my GC email account, and I will try to get back to you as soon as possible. Good luck on your test on Thursday.